Okay, really quick, I want to catch us up on the last few slides regarding pH so that we can be ready with buffers starting Thursday. So here's where we ended in lecture, and what we had learned, kind of the last thing we learned is if we have concentration of H+, we learned how to calculate pH. And we know that if you take the negative log of that concentration of H+, that is equal to pH. But I'm going to read this question. What if we are given pH and we want to know the concentration of H+? Essentially, how do we work backwards? And this right here is a link to a YouTube video that walks you through this step by step. I think it's very helpful. So I try to provide resources like that every so often, but watch that if what I explain here just doesn't click with you. Maybe hearing it in a video like that, it's real quick, couple minutes, will help. So here's our equation, pH equals negative log H+. The first thing we're going to do to answer this question is we're going to move the minus sign over. If pH equals the negative log, then it's true that negative pH equals the log of the concentration of whatever you're taking here, H+. Okay, then secondly, you take what is called the antilog. And in an antilog, you're going to do a base 10, and you're going to raise whatever your term is to the exponent. So on the right side, or the left side of the equation, we're going to raise negative pH to become our exponent. And we're going to do the same thing on the right side of the equation, 10, and then this portion, log of H+, will become our exponent. And so what we have is 10 raised to the power of negative pH is equal to, now the 10 and the log cancel each other, an antilog undoes a log, so we're just left with the concentration of H+. So if you want to find the concentration of H+, you would plug it in as an exponent, make it negative, and do 10 to the power of that, and that gives you concentration of H+. So let's practice doing that. Grab your calculator. If pH is 8, what is the concentration of H+? So we will do 10 to the negative 8, and what you should get, if your base number is 1 here, which it is, 1 times 10 to the negative 8, then you should know that, pH is 8, that is your concentration of H+, 1 times 10 to the negative 8. And if pH is 4.5, so this is nice when pH has no decimals. When it's a whole number, it's very simple. You really don't have to do a whole lot of calculating. But if your pH has a decimal on it, like these next two, then you need to put that in your calculator. So we'll do 10 to the negative 4.5. We don't like to leave decimals in exponents. We like them to be nice, round, whole numbers. So do 10 raised to the negative 4.5. And you should get that equals, how many zeros is that? 1, 2, 3.2 times 10 to the negative 5, I think is what we got. And that's molarity here, units of molarity. That equals the concentration of H+. And for this last one, you'll do 10 to the negative 12.3. Oh, and this is asking for concentration of OH minus. All right, so there's two options here. You can do 10 to the negative 12.3, and this is going to give you the concentration of H+. Then you can plug that into kW, okay, because kW equals concentration of H+ times the concentration of OH minus, and you can divide by both sides by the concentration of H+. So kW divided by H+ is going to give you OH minus, or you can actually, before you even do the first step, the second thing you could, so this is approach number 1. Approach number 2 is you could say, I know, we introduced this other equation where pH plus POH equals 14. And you could plug in pH here, so it's 12.3 plus POH equals 14. So essentially, if you subtract 12.3 from both sides, you're going to get POH, which is going to be equal to 1.7. Then you just take the negative log of that, okay, to get the concentration of, if POH equals this, then we can do 10 to the negative 1.7 to get the concentration of OH minus. I'm running out of room here. So either way, if you want to do the first route, we'll do 10 raised to the negative 12.3, and I got 5 to the negative 13. So then we would come over here, and we would plug that in for H plus. So 5 times 10 to the negative 13. So we divide by 5 times 10 to the negative 13. We would plug in kW as well, which we know is 1 times 10 to the minus 14, and divide that. So then 10 to the negative 14 divided by 5 times 10 to the negative 13. And I got a concentration that OH minus equals, I'm out of room here, but it should be 0.02, and that's units of molarity. Or you could write 2 times 10 to the minus 2. And if you do the pH-POH thing, then 10 raised to the negative 1.7 also gives you 0.02 molar. So 2 ways to solve that there. All right, moving on. Another thing to know about the pH scale is that it's logarithmic. We understand that because we use the log function to calculate pH. But what that means is that if pH is increased from 6 to 7, so if we have a change in pH, how does that change the concentration of H+? It will decrease from 1 times 10 to the minus 6 to 1 times 10 to the minus 7. 10 times less H+. So if you increase in pH, you're going to decrease in H+, and it will tell you by how much. A 1 pH unit change results in a 10-fold H+ change. A 2 pH unit change, if we go from 6 to 8 or 4 to 6, results in a 100-fold H+ change. And what about a 3 pH unit change? What would that mean as far as how much your H+ is changing? That would be a 1,000-fold change in the concentration of H+. So some key relationships to know here. As you increase in pH, as you go up the pH scale, you decrease in your concentration of H+. And proportionally, you increase in your concentration of OH-. This is a very, very key relationship to know. Vice versa, as you decrease in pH, you increase in the concentration of H+, and you decrease in OH-. As you go down in pH, you become more acidic. More acidic means you have a lot of H+. H+ makes something acidic. Higher pHs over here are basic pHs, and you have low amounts of H+. And then really quick, we'll work this problem. It says normal blood pH is 7.4. That is physiological pH. Patients with diabetes and chronic hyperglycemia can have a condition called ketoacidosis, where their blood pH becomes too low, too acidic. So we call it ketoacidosis. It's an acidic blood pH. At a pH of about 6.9, a person is in danger of falling into a coma. Hello. What is the H+ concentration difference? What is the difference in the number of ions between this pH and this pH? Okay, those pHs are only off by like 0.5 of a unit change. So what is the difference in H+ concentration? How do we find that? Well, we're going to take these pHs and undo them and get the concentration of H+, and then we'll subtract the highest or the lowest from the highest. So we'll do 10 to the negative 7.4 equals 10 to the negative 7.4, 10 raised to the negative 7.4 equals, oh goodness, this doesn't give it to me in scientific notation. Let me count the zeros. 1, 2, 3, 4, 5, 6, 7, 8. So 4 times 10 to the minus 8 molar H+. And then for the second one, 10 to the negative 6.9 equals 1.26 times 10 to the minus 7. concentration of H+. So this one is larger. Okay, so there's more H+ here because it's more acidic. So we'll do 1.26 times 10 to the minus 7 minus 4.0 times 10 to the minus 8. And we will find the difference here. Which is 8.6 times 10 to the minus 8 moles per liter of H+. That's the difference. Okay, look how small this is. If we simply change the number of hydrogen ions in our blood by this amount, that is 0.000000086. I think that's right. Okay, then we could fall into a coma. So our bodies have to be very good at regulating our pH, and they are, thank goodness. And so anyways, that's it for pH. We're going to pick up with buffers tomorrow.